Hello, welcome to TGM tutorials. In this lesson we shall look at 3x3 determinants. This will be lesson 4. Let's look at the definition. If we let that to be this matrix to be a 3x3 matrix, the determinant of, let's say this matrix is A, the determinant of A is defined as state A, which is equal to A11 date. Now I want you to notice something. This A11 is the entry here. We have A11 minus A12, which is this entry, plus A13. Now where are we getting these signs, negative and positives? So for a 3x3 matrix, finding the determinant, we multiply by the signs. If we decide to use the first row, multiply the first row entries by positive, negative, positive respectively, and negative, positive, negative the second row, and positive, negative, positive for the third row. So if we decide to get A11, the matrix here we are getting is by deleting the row and column where this entry lies, and we'll get this matrix, and this is the matrix that we have here. Same applies to the second. Deleting this column and the row, will get this, that, and that as the entries, which is this one, plus A13. Deleting this column and this row, will get this matrix, which is that one. Find the determinant of that one. So that will give us the determinant of the matrix. Now I want you to note that the expansion of the determinant of A above is in terms of the first row, and any row or column can be used to obtain the expansion of the determinant. So if you want, you can use this row to find the determinant. If you want, you can use the second row to find the determinant. If you want, you can use the third row to find the determinant. Or you can use the first column to find the determinant. You still get the same determinant. You can use the second column or the third column to find the determinant. Let's look at this example. We are finding the determinant of A, where A is equal to a matrix 1, negative 2, 3, 2, 0, 4, negative 3, 1, 5. The determinant of A will be equal to, now we are considering the first row, so we'll be using entries in the first row. We're multiplying by 1 multiplied by this matrix 0, 4, 1 and 5, minus negative 1 multiplied by determinant, side 2 we get negative 1, we are getting 2, 4, negative 3 and 5. We get 3 plus 3 multiplied by 2, 0, negative 3 and 1. Here we are supposed to have the 1. That will give us 5 minus 4, which is negative 4. 5 minus 4, which is 5 minus, this is 5 multiplied by 0 will give us a 0 minus 4, that is negative 4. And here we have 2 times 5, that is 10. plus 6, that is 16. This is 2 times 5 will give us a 10, plus 12, that will give us 22, multiplied by negative here, positive, will give us plus 22, plus 2 times 1, that is 2, and the determinant will give us negative 4 plus 22 plus 2, which is giving us 20. Okay, let's look at the properties of 3 by 3 determinants. Like in the case of 2 by 2 determinants, the following properties of 3 by 3 determinant can be proved. If we let A be equal to a matrix, a 3 by 3 matrix, the determinant of A is equal to the determinant of A transpose. These properties, they are just the same as properties of 2 by 2 determinants. They are just the same. The determinant of matrix A is equal to that, and the determinant of A transpose will be the same. If one row or column of A is a scalar multiple of another row, then the determinant of A is equal to 0. Okay, and these are the properties. We have 5 properties. The changing 2 rows or columns of A changes the sign of the determinant. If 2 or 1 row, if 2 rows or columns of A are identical, then the determinant of here we suppose if two rows or columns of A are identical, then the determinant of A is equal to 0. And the 5th property is that if one row or column of A is a scalar multiple of another row or column, then the determinant of A is equal to 0. Okay, let's look at this example. Now, in this example, we are finding the determinant using the properties we've discussed. From this matrix, I want you to notice something, that we have 2 columns which are identical. This column, the first row and the third row, they are identical. They are one and the same. So using the 4th property, which is if two rows or columns of A are identical, then the determinant of A is equal to 0. So without even wasting much time on finding the determinant of this matrix, we know that the determinant of this matrix is equal to 0. If you want to prove that, we can prove that. Let's say if we consider 2, we are going to have this matrix 0, 2, -1 and 3, minus -1. We are considering the first row, -1. We're going to have the matrix 1, 2, 2 and 3, plus 3, which will give us 1, 0, 2, -1. This will give us 2 multiplied by 0 times 3, that will be 0, minus -2 times -1 times 2, that will be -2. So this will give us a +2. +2. This is plus 1 multiplied by, this is 3. This is 3 minus 4, which is -1, plus 3. 1 times